Hello everyone. Now I am going to discuss about SN2 reaction. It's also called upon bimolecular nucleophilic displacement reaction. So why it is called upon bimolecular? According to the chemical kinetics, the rate of the reaction it depends upon the concentration of the reactant. So in this reactant, the concentration of alkyl halide as well as the alcoholic base it depends upon. So here I mentioned about that the rate of the reaction of SN2 reaction, it's a concentration of A, it's nothing but alkyl halide which have the experimental value number 1, and B, it's nothing but it's an alcoholic base, again the experimental value 1. So the 1 and 1 plus 1 I got the number 2. So this is called upon bimolecular reaction. So generally this reaction is carried out polar aprotic solvent. So what is it polar aprotic solvent? What is the difference between polar protic solvent and polar aprotic solvent? Polar protic solvent for SN1 reaction. For SN2 reaction, polar aprotic solvent. The aprotic solvent cannot to form the hydrogen bond towards the substrate. For example, DMSO. What is a DMSO? Dimethyl sulfoxide. It is a dimethyl sulfoxide. S double bond O and a methyl group. And what about the DMF? It's a dimethyl formamide and acetone. So these are all the example of polar aprotic solvent. So in a given reaction, the supplements or it's a background behind from polar aprotic solvent means it is a SN2 reaction. So now incoming nucleophile interact with the alkyl halide. So it is talking about the bond formation and halide bond breaking while form new carbon and hydroxyl bond. So now what will happen? Simultaneously both bond breaking and bond formation can be occurred. Okay, so this reaction it is a second order kinetics. It's a single step reaction. So in SN1 reaction we identify the intermediate of primary carbocation and tertiary carbocation, secondary carbocation. But in this SN2 reaction we unable to find the no other intermediates. So it is a simultaneously, okay, both bond formation and bond breaking happen in simultaneously. And this is also it's called upon according to the stereochemistry aspects point of view, it's an inversion of configuration. So what is the configuration? So if it is according to the atomic weight, okay, atomic weight, if it is a chiral carbon consists of the different number of atoms. So that will be incident to the PPL. It can rotate clockwise direction mean it's called upon or configuration. If it is anti-clockwise direction means it is a S. So in this reaction, before treating the reaction, the alkyl groups are, it is a R group. If it is R group means, clockwise direction means after nucleophilic attack, it will be convert into the anti-clockwise direction. So this is inversion of configuration. So let me discuss about the example of methyl chloride. So here I have the methyl chloride. The methyl chloride it's treated with the aqueous KOH. So what is the aqueous KOH? The aqueous KOH it is an ionic form. So definitely here it will form the nucleophile of the hydroxyl group. So once I hydroxyl group it replaces with the halogen atom. So here I'm got the hydroxyl group. So methyl chloride it's converted into methanol. So now listen carefully. Let him discuss with that mechanism, then only you can understand okay how it is product we are going to get that, okay, from the inversion configuration point of view. So now initially from the aqueous KOH, it can liberate into the potassium plus and OH minus. So this is our the nucleophile. This particular nucleophile, okay, the center of carbon here will be present. So in this hydroxyl group of O and carbon, here the new bond will be formed. So once it is migrate towards the carbon as soon as possible. Now what will happen? Simultaneously this bond, okay, this is the halide bond. The halide bond is going to be cleave that. So this is the intermediate state. So in this case, between the nucleophile of this system and center of carbon, the new bond formation is takeover. So now what will happen? At simultaneously, at the same time, between the carbon and halogen, okay, the bond breaking it's occurred. So now what will happen? As a result, a new bond formation of product will be appeared. So now what will happen? So once I nucleophile are connected to the center of carbon, so the connecting of the three number of hydrogens are it's straight away from that. Okay, so all are in the same planar structure. So once I complete formation of the nucleophile, okay, the at the same time what will happen? The leaving group of the halide it's completely eliminated. Okay, so this reaction is between the methyl chlorine and hydroxyl ion. So it's follow the second order kinetics. Therefore, it's called upon what? It's called upon bimolecular reaction. So in this reaction, here I have the concentration of methyl halide and concentration of aqueous KOH. That also what? It's participating. Okay, the full rate of the reaction depends upon the concentration of alcoholic base as well as methyl halide, methyl chloride. Okay, so now the stability order of the SN2 reaction. Okay, it's a primary alkyl halides are more reactive than secondary alkyl halide and tertiary alkyl halide. The reason is the steric hindrance. So how it is steric hindrance? So here I mention about that primary alkyl halide intermediate and secondary alkyl halide intermediate and tertiary alkyl halide intermediate. The first case of the alkyl halide. So here I have the one bulkier group of that methyl group. So now the approaching of the nucleophile, there is no disturbance. It's freely attacked to the center of carbon. Now what will happen? At the same time, halide group, the leaving group of halide group also is occurred. But in secondary alkyl halide, okay, comparison of the first case, I have the one methyl group. But here I have the 1 and 2 methyl group. So now the approaching of the nucleophile realize that it's a more difficult to approaching of the center of this carbon. So now what will happen? The comparison of the first case, okay, the secondary alkyl halides of approaching of the nucleophile, it's feel very difficult. Okay, and what about the tertiary alkyl halide? In the tertiary alkyl halide, the center of carbon consists of the three number of bulkier group. So now once the approaching of the nucleophile of the hydroxyl, it's more difficult to interact with the center of carbon. So that's why it is a least stable. So bulkier group hinder the approaching of the nucleophile. Okay, and commonly if you are suppose the substrate, if it is a comparison of that same alkyl halide, means we give the preference for that alkyl fluoride, it's a less reactive than alkyl chloride and alkyl bromide and alkyl iodide. The why it is a reason, the iodine it is a largest atomic sizes. The leaving of the halide will be easier in the more atomic size of the alkyl group. Okay, so now here I'm mentioning about the index questions. So this question it's in your NCERT books, index question from 6.7. Which alkyl halide from the following pairs would you expect to react more rapidly and SN2 mechanism? Explain your answer. So now question number subdivision 1. Subdivision 1, what is a common name? It is a N-bromobutane. And what about that next substrate? It is a 2-bromobutane. So here I have that primary alkyl halide. This is the R group. This is the halogen. Okay, and what about the second one? The second one, the halogen, the CX nature of the CX bond, it's connected to the 2 number of alkyl group. So therefore it is a secondary alkyl halide. Okay, so what is the reactivity? The secondary alkyl halide have the more bulkier group. So therefore the nucleophile of the the approaching of the nucleophile will be, it's very difficult. Okay, because the reason is 2 bulkier group will be present. So what is that answer? The answer is a N-bromobutane. It is a more reactive. Okay, this is the answer. What about the second case? In subdivision 2, here I have that 2-bromobutane and second substrate it is a 2-bromo 2-methyl propane. Okay, it's a butane, 2-bromobutane, and here I have the 2-bromo 2-methyl propane. So now this is the category of the secondary alkyl halide, and this is the nature of the CX bond. This is the nature of the CX bond. Here I have that 3 number of alkyl group. So this is the tertiary alkyl halide. So which is the more reactive? Obviously the secondary alkyl halides are more reactive. Why? The reason is the secondary alkyl halide is a less steric hindrance. The tertiary alkyl halide has the more steric hindrance. More steric hindrance will be present. And what about the subdivision 3? In subdivision 3, this is the nature of the CX bond. Here also what? Nature of the CX bond. But what is the problem here? Here both are, it is a primary alkyl halide. This also what? Primary alkyl halide. So if it is both are primary alkyl halide means we need to focus on the steric hindrance. So what is the steric hindrance? So here I have the methyl group and methyl group. So in this system 1, 2, 3. In the third position I have the methyl group. But in this case I have the second position. So now the substitution of the methyl group, it's far away from the CX bond. But here it's closer to the CX bond. So now the approaching of the nucleophile, comparison of this one, okay, here it's more reactive. So answer, it's a first one. So what is the IUPAC name of the compound? It's a methyl group. This is the bromo group. So 1, 2, 3, 4. It's a 1 bromo, 1, 2, 3. 1 bromo, 3 methyl butane. Okay, so this is the correct one.